So today we're gonna start a chapter, section 2.2. So let me go ahead and share my screen in here. Okay, so let's see. Open. Not that one. Okay, hold on a second. Turn the camera, mute, open tray, screen share. Okay, so let's see if you can see my screen at this point. Can everyone see my screen right now? Give me a yes or no.
Yes.
Okay, all right.
Yes.
Okay, good. So today we're gonna start a section 2.2. You're gonna need to finish the chapter 2 this week. This, probably 2 or 3 days. Hopefully you already started 2.2 on your own. Okay. I just want to go over that pretty quick for this section and up to 2.3, 2.4. So this section, you need to know how to graph the stem and leaf, okay, and the dot plot, and interpret the qualitative data using the pie charts and the Pareto chart. And how do you graph the pair data using the scatter plot? And that is the one I'm going to show you in a TI-83 or 84 calculator, okay? A lot of this concept, you can either watch the video or read it from the textbook, but the calculator will be my emphasize, okay, in here. So I want to emphasize how do you use your TI-83 or 84 calculator. You can also download an app from your cell phone if you do not have a handset calculator, because the digital calculator is massive. Some of them you can download it for free. Some of them they only pay $4, for the entire thing that way. Okay, so that is the TI-83, 84 calculator. So what is a stem and leaf? Actually, this is organized the data into two parts. Okay, one part is called a stem, the other part is called a leaf. So 21, we put a 2 on the one side. This side is called stem, and then put a 1 in here. If you have a 321, now you have to have just 1 2 right here and 3 1 on the right side. Okay, so look at this one right here. You got 225, so you have a 1 2 and then 2 5. And then 6 7 8 in here, and similar with the 30th, right? So you only write down the 3 on the left, 0 on the right, and then you have a 236. So you need to write down 26. One thing is those data need to line up together. Okay, it's kind of line up together. And usually you want to also put a little bit legend on the side. Say like I said, this is 26. All right. So what is the legend? You put a a little bit bar right here, right? And then write down this one is you know, 2 bar 6, and that is equal to 26. Okay, so put a little bit legend right there so people will understand that it's 26 that way. All right, otherwise it's very easy to organize. Okay, if you have this many data, you might want to go through the data once and then put it in a, you know, this one is called unshort. Okay, put an unshort stem and leaf and then go through the data once and then eventually short them. Okay, so and then you put the key right here, right? So this key 10 bar 2, that is 102, not 10.2. So put a little bit a key right here so people will understand what does the data represent. So this one, you can see the minimum will be the 16, right? If you put this stem and leaf, it's pretty easy to like organize that way. So the first number will be the first number is the minimum, the last number is the maximum. Okay, so the first number here, pin changes. Okay, the first number, that means the minimum. All right, minimum here will be 16. Okay, and then you can see the last number will be the maximum. So the maximum number here will be 149. All right, so that is what you can see from here. Okay, I'm trying to see someone trying to get in. All right, so that is the minimum and the maximum in here for this stem and leaf. All right, so pretty straightforward. The second one is called a dot plot. Dot plot is just very easy. You put a dot, one dot on the top of the number. So for example, if you got 225, right? So you have a 25 right here. You put a 2 dot on the top. And one thing, this 25 is not a maximum. Maximum is the rightmost. So the maximum is right here. Maximum will be 45. And then this one will be the minimum. Okay, the leftmost is the minimum. The rightmost is the maximum. All right, this one got a longer one. This is just the most frequent one. And then we have a 36, also got 236 right here. Okay, you have a 236. So those are the dot plot. Okay, so this is kind of the dot plot in here. So you can see, wow, we have a maximum number is right here, is 149, right? And then we have a minimum number right here is about just 16 in here, okay? And then you can see, wow, 30 is, you know, probably 29 got the most data right here. So you can see kind of this pretty easily and very easy to graph the dot plot in here, okay? The other one is called a pie graph. Pie graph, you can put it in the Excel, very easy to graph the pie graph. And usually if you have a 2 to 7 category, pie graph will be easy to read. If you have something more than that, the pie become too small and very hard to read, all right? So we don't recognize, you know, when you got too many data, we don't recognize using the pie graph, all right? So for example, this one is the degree type and by the number. Associate, this is in 2014, right? Number of degree N in thousands showing in US in here. So associate degree is 1,000, you know, you can say like a 10,000, 1003 and in thousands, okay? So total degree is 178,000, all right? And then this will be 1 million actually, okay? Associate will be 1 million, and then 3,000, you know, in here, right? There's a 1,000 zero, so that's 1,003,000, okay? And that's 1,870,000 in here. All right. So those are the degree, using the pie graph, right? And then this one is telling you will need to go to find the total and then find the percentage and then multiply 360 degrees to see how much pi you do in here. But we usually don't really ask you to do this one by hand, okay? You can just plug it into Excel and the Excel will automatically calculate for you, all right? So looks like the bachelor degree got the most in here, 49.1%, right? Associate degree is 26.4 degree. And when it got to the doctoral degree, it's only like less than 5% in here, all right? So that is this type of the pie graph. And this pie graph is pretty clear to read because it only have a 4 category, right? Another one is called a Pareto chart. Pareto chart actually is a bar graph, okay? This bar graph is in a descending order, okay? Put it in a descending order in here. And that is called a Pareto graph, all right? So basically, it's just a regular bar graph. We'll put it in a descending order, all right? So the top 5 cause of the death in US, right? A lot of people, taking the statistics, they measure in the medical area. So you can see like the top 5 cause of the death in US, heart disease is the #1 killer in here. Okay, so the heart disease in here. So if you learn how to do the CPR, at least you probably can help some people in need in the emergency one, right? That kind of thing. All right, and the cancer is the second one, chronic lower respiratory disease, accident. Unfortunately, accident happens, but that looks like a pretty unnecessary death for those kind of things. So we have to be very careful that way. Don't cause any accident, right? And then a stroke, that kind of thing. So those are the top 5 causes of death in US. Okay, graphing the scatter plot. Okay, so scatter plot is you put some data, one relationship on the x called the independent variable, right? And then you put a dependent variable on the y-axis. Or sometimes this y is also called a responder variable, okay? X is an independent variable, or sometimes it's input variable, or called a exploratory variable. They have a several names for that, right? And y variable, y is the output in here. So if you look at this scatter plot, if you do a little bit of regression line, this is going down, right? So it's like the whole thing is going down in here. All right. So I'm going to show you how to use the calculator to do this type of scatter plot in here, because it's very, very helpful in our later chapter. All right. So we're gonna be able to do the scatter plot in here, and then that is the petal length, the increase on what tends to happen to the petal width. Okay, so you can see this is a little bit positive, positive. Looks like a positive kind of, I'm not drawing too straight right here, but if we're trying to do the linear, that is a little bit like an increasing one, right? So when this length increase, the petal width is also increased that way. All right. Okay, time series is the scatter plot. You put it in a you put a line together. So if you have a scatter plot and then you connect all the dots together, that become a time series. So time series is using to represent the data over a period of time. Okay, so this time series, you can have 10 years, you can have 20 years, and this graph will be still very clear. All right, so we write a time series, we write a scatter plot, those kind of things. All right, so we want to construct a time series in this table showing the year and the motor vehicle theft, okay, and the burglary in here in millions. So looks like in 2005, we have a 1.24 million of vehicle thefts, okay? And by the time of 2015, looks like with the technology increase, right? So the vehicle theft is also decreasing, So we can see like this should be a decreasing relationship in here, and we're gonna be able to do the scatter plot to graph them. All right, so that is my emphasis on this class. How do I do the input this data into the calculator and do the graphing? All right, so I get my calculator open in here. Okay, so we need to be able to input this data into the calculator. Okay, this is TI-84. 83 interface is exactly the same. All right, so we go to state. All right, STAT, anything with the STAT is our favor. So go to state, edit, you're gonna hit enter, and then you'll be able to input the data. We usually input the X data into, L1. Input the Y data into L2. Okay, so my X here is starting from 2006, actually 2005. All right, and then 2006. Ooh, hold on. Okay, and then 07 all the way to 2015. Okay, so that is my X. And then I need to input a Y value in here. So this is the vehicle theft. So that's 1.24. Okay, and then 1.2, 1, 0.96, 0.8, 0.74, 0.72, 7. Okay, so whatever you input, make sure you have a pair. Okay, so that means this one I have a 10 data on the L1. I also need to have a 10 data in L2. All right, if one side is longer or shorter than the other, you won't be able to graph because you cannot find a pair. All right, so that is important. Okay, so we're gonna second more is quit. Okay. And if you hit a second and then hit this button, it will go to the execute the blue color. So I want to go to the state plot in here. State plot is right here, is blue color. So I need to hit second Y equal to, and that will give you the state plot in here. Okay, and then you hit enter. The default of the scatter plot is always off. So we need to turn it on. So when it's highlight on, hit enter. And then you move down, make sure this on is highlight. If the on is not highlighted, you won't graph. Okay. All right. So the first one is the scatter plot. The second one is the time series. All right. So we're gonna do the scatter plot first. And I want my L1 into X, my L2 into Y. So if you input this way, you don't have to change anything, right? And if for some reason you forgot, like if you input you Y into L3, right? So you don't have to re-input everything. You can just change this L2 into L3. Okay. So how do you change L3? L3 is right here. Okay, L3 right here. So you have second 3. That will give you L3, right? And then if you input your X into L2, now you have a second 2 into L2. So you can just change it. You column list in here. You don't have to re-input the data because re-input the data will be a lot of work. All right. But if you put in a default, you don't have to change anything. So I'm going to change it back to default, which is my L1. All right. And then my Y is in L2. So second 2 is L2. All right. So that is the one I have in here. And then we're going to just go ahead and hit graph. All right. You can change it into different color in here, but some calculator don't let you change the color, right? We're going to go ahead, hit graph. When you hit graph, you probably don't see anything because this coordinate is kind of 20 by 20. It couldn't show the number we have in there. So we're gonna go to Zoom. Zoom number 9, Zoom state, Zoom STAT is our favorite. So I'm gonna just go to Zoom number 9. So now you can see all this scatter plot in here, okay? So this one is a really good decreasing in here, all right? Decreasing, and then this tend to a little bit flat in here, all right? So that is my scatter plot in here. If you want to change this one into time series, you just need to go to second y equal to, go to state plot, and then change this one. You still have to highlight on, and then change this one into second one, all right? And then hit enter. Now your second one is enter, the rest is the same, right? And then this, we are giving you the time series in here. It will connect all together, all right? So those two are pretty similar. If you have a scatter plot, you usually know how to, you see how the data look like that way, right? So personally, I prefer the scatter plot because I can kind of imagine how the data look like that way. All right, so that's the original data point. Okay, so that is the one I try to emphasize on how to use the calculator to graph this one. The reason we use the calculator because you can find the equation later on your own from the calculator directly. Okay, so that's the good thing in here. All right, that is how the time series look like in this case. Okay, so there's another data, which is number of the absent and the final grade. And you can see this is around a scatter plot, right? So just like the number of the absent and the final grade is in a negative relationship. So what does negative relationship mean? That means, if your number of the absent increase, the final grade actually is decreasing, right? So it's decreasing. So that is called a negative relationship in here. All right, so that is our section 2.2. Did anyone has any questions? Let's see, do we have any questions? I don't see. If you have any question, you can post it in here, or you can post it in here, or you can raise your hand, jump in to talk. Okay. All right. So let's go to the next section. Okay, 2.3 is the major or the central tendency in here. So that means we need to be able to find a mean, median, and mode, and then find a weighted mean in here, okay? And I will also showing you how to find a weighted mean using the calculator as well. Okay, so the central tendency here, we have a triple M, we call it triple M, right? The triple M here is the mean, median, and mode in here, all right? The mean here, we have population mean, and we also have a sample mean. Actually, these two calculation is the same. It's just using a different symbol. All right. So when you have a population, we're using this Greek data called mu. All right. This one is kind of pronounced mu. Okay. In here, and then for the sample, we're using the X bar for the mean. All right, this is all equal to the sum of the X and then divided by the sample. The N is the total population, and this N is the sample size. All right, so basically the population mean and the sample mean calculation is the same. It's just using a little bit different different character to represent. All right. Okay, so look at this one right here. This one Italian is a sample mean, right? Italian is a sample. The weight in pounds for sample of the adults before starting the weight loss study at least, with the mean weight of all these adults. Okay, so we have 1, 2, 3, 4, 5, 6, 7, right? We have 7 people in here. And I just add these 7 together and then divide by 7. That's it, okay? Since this one is a sample, all right, so I'm using the X bar for the sample, okay? So you add all these 7 together and then divide by 7, and that's it. So this is called simple mean, which is pretty simple. All right, so we want to find a median on this data set. In order to find a median, you have to line the data up. So you have to put in an ascending order. So that means you need to put this data in an ascending order in here. So from left to right is in an ascending order, okay? And then we have we have a 7 data. We have a 7 data set. So 7 is N7 is an R number, okay? 7 is an R number. So when you have an R number, the median is exactly in the middle one, all right? This is the R number, so we have a median. So look at this one right here. I have a 3 to the left and then 3 to the right, right? So this one is exactly in the middle. So now this is called a median, okay? So the median weight here is 268. All right, so if we have this one, this time is only 6 data. All right, so if I have n equal to 6, look at it. We have a 1, 2, 3, 4, 5, 6. So if I put a 6, my middle is in here, right? And that means there's no data in the middle exactly. So how do we find the median? If there's no one exactly standing in the middle, we're gonna add these two together. All right, add them together and then divide by 2. All right, so the average for the middle two will be the median. All right, so look at this one right here. You add these two together, either 235 and 268 together, divided by 2, because this is 6 entrance. 6 is an even number. All right, so since an even number, you don't have a number exactly in the middle. So we have a 3 to the left, 3 to the right, right? So how do I find my median? I add the middle two together and then divide by 2. So 251.5 is the median. All right, another one is called mole. Mole is the greatest frequency, or sometimes called the most frequent one, okay? One of the data set, you can usually, most of the time, it has 1 mole, all right? And you can have a 2 mole, or call my model as well. And sometimes if all the data only appear once, that means the data doesn't have a mole. So we call it no mole in here, okay? So look at this one right here. We have a 235 to 235, and looks like the rest all only appear once, right? So for the mole for this data set will be 235, because 235 is the only one appear twice. That's the most frequent one, right? The rest is only appear once. Okay. All right, so look at the mole for this political party and the frequency here. What is the mole of this response? Okay, a political debate, a sample of the audience member will ask to name the political party to which they belong to. Okay, their response is shown in this table. So 46 of them said they are Democrat. 34 said they are Republican. 39 said they are independent. The other 5 who said they don't know. Or they just, choose other that way. Okay, so what is the mole? Well, we said mole should be the most frequent one, right? So which one is the most frequent one? Oh, we have a highest frequency here is Democrat, all right? So Democrat is the mole in here, okay? Because that's 46. All right, so we're gonna be able to compare the mean, median, and mole. Sometimes, you like to use the mean. Mean is the average for everything, right? It seems really good to do a lot of things, but sometimes the mean can be a little bit in a disadvantage area if you have outliers. So what does outliers mean? That means really big or really small number. That is called outliers. Extremely small, extremely big number is called outliers. So if you include a really big number into the mean, everyone's average is gonna be higher. If you include a really, really small number to the mean, and then you average it together, well, now this average is gonna be much lower than, than a lot of people's average, right? So that means the mean we are affected by the outlier. So that is the disadvantage in here. Okay. The advantage is you put everyone into account. All right. But the disadvantage is you're gonna be afraid by the outlier, either really big or really small number. So if you have an outlier, median will be the better choice, because median it only uses the middle number, so it doesn't affect by the outlier. Okay. So that's the median in this case in here. All right. So this one, if we have this data set in here, look at this one. I have looks like I have a 65 right here. The age in the class, right? We have one actually is at one time, one of my students, she really wanted me to know her age. She was 75 in my math class. So that was my oldest student, right? So this one is 65. It's not as old as my student at one time. Okay. But if you include a 65 into the class average, everyone's average age is going to be higher. Okay. So if you're using the bin, all right, we have put a 20 student and include a 65, the average will be 23.8 years, right? Almost 24. But you can see, look at this data, look at that. How many of you have almost 24? None of these, look at that, none of these. We only have one or two. We probably only have 2 students is about 24, right? There's 2 24 and 165. So looks like this average seems a little bit inflated that way. All right. If we're using a median, add the middle 2 together, divided by 2, we only have a 21.5. So if 21.5, I think it will be more accurate to represent this table. What do you think? All right. Better than 23.8. Okay. So you can see, because we have a lot of cases here, got 20, 21, 22. So if you have a 21.5, I think this is more representative for this table. Okay, so that is the advantage and disadvantage of the bin. You know, this we are affected by the outlier. Okay, so I will choose for the median in this case. Okay, so comparing the mean, median, and mode, sometimes the median is always in the middle. Okay, the median is always in the middle. If this data has outlier on the right, so what kind of outlier on the right? So this is kind of we call like a skew to the right. Okay, if I have this kind of graph skew to the right, that means the bin gonna be going to the, you know, follow the tail, right? The bin will be in here, will be on the left side. Okay, and then we prefer like the data called a symmetry. Okay, if I don't have any outlier and then the data is kind of like a bell curve, right? Symmetry. So what happens with this kind of symmetry? Symmetry, the mean, median, mode will be all in the middle, triple M. All right, triple M, mean, median, mode will be the same, will be in here. That is our ideal situation. Okay, and we'll talk a little bit more about this later on. All right, the next thing here is called a weighted bin. Okay, so some of the bin is weighted differently, just like the course grade, right? If a homework, like I said, 20%, and then the test is 15%, for example, and then the quiz is 18%, right? So each weight is differently, it's weighted differently, different category. All right, and how do you find your course overall grade at the end? Well, now that is called a weighted bin, right? So I usually tell people, say by the end of this course, you should be able to calculate your own course grade, right? If you don't, you should not pass this course, because we did teach you in here. All right, it's called a weighted bin. Okay, all right. So in order to find the weighted bin in here, you will need to using the data value multiply the weight. So this one you have to multiply first before the big sigma, before you add them together. All right, and then divided by the sum of the weights. So that is called a weighted bin in here. Okay, so look at this one right here. If you want to find the GPA, the grade point average, right? And then you have this C is usually C is 2 points, D is 1 point, F will be 0, A will be 4 points, B will be 3 points. So how do I find my GPA? with GPA is weighted bin. All right. So we have a okay. So we have this x bar. We are equal to the sum of x times w over the sum of the w. Okay, so we have to multiply each one. So this C is 2 point, D is 1 point, that's 4 point, that's 2 point, that's 3 point, that's 2 point, right? So we're gonna have a 2 times 3, 2 times 3 plus another 2 times 3. This second one is 4 credit hours, so that's 4, right? So we have a 3 credit hour plus 4 credit hour plus that's 1 credit hour. All right, this 1 credit hour got a D, so that's 1 times 1. Okay, and then plus this is 4 times 3 plus 2 times 2. Okay, and then plus 3 times 3. All right, so we add a weight together, so that's 3, 2, 3. Okay, so we got to do the calculation. So that is the total credit hour is the weight, right? So we have a 7, 8, 11, 13, 16 credit hours. Okay, and then 2 times 3 will be 6 plus 8 plus 1 plus 12 plus 4 plus 9. Okay, so we're gonna go to add them together in here, right? And then add them together, this total is 40. So you have a 40, so you have a 40 divided by 16. All right, 40 divided by 16 in here. Okay, all right, so 40 divided by 16 is 2.5. So the GPA point, the grade point average for these courses are 2.5. All right, so that is how you find your grade point average, right? You using the course grade multiply the credit hour. Okay, so and then multiply and then add them together. So that's the sum. Okay, and then the denominator will be the total credit hours in here. So that's the total weight. Okay, sometimes we also need to be able to find the bin for the frequency distribution. You know, that frequency is similar to like the weight we have in here. But if the table have a classes, we have to find a bin point first. Okay, we need to be able to find a bin point first, and then multiply the frequency, and then multiply together before you add them. All right, so that is this one right here. So how do I find a bin point in here? The bin point is use the lower class limit plus the upper class limit divided by 2. So this is giving you the fourth step to find this weighted bin, right? So step 1, you have to find a bin point, and then step 2, you have to multiply the frequency and then add them together, and then find the sum of the frequency and then do the division. Okay. All right, so this one, if you already given you the class bin point, now you don't have to find on your own, and then you have a frequency, so you need to use 172.5 times 3, and then add them together, okay, and then divide. So that is the weighted bin in here, okay. You can also put this weighted bin into calculator as well, okay. So how do I, okay, so let me go back here to show you how to use the calculator to find this whole thing. All right, so if I want to just find the bin, right? There's one way to find the bin in here in this one. So let's look at this one right here. I have at least 20 data. How do I find the bin from the calculator? Well, you can add them together, but you can also use this calculator to find the bin. So let me go ahead and go to state again, go to edit. All right, let me show you one thing to clear the data. If you go to highlight the L2, go to the very top, hit clear, enter, everything will be gone. So you don't have to delete one by one. Go to the very top, highlight L1, hit clear, enter. Everything will be gone, okay? So now we can input the data in here. All right, I'm gonna just input like a 6 data in here. So I can, instead of using the addition, I can using the state to find the bin. So I go to state here, and then go to the second one, go to the calculation, okay? Go to the calculation, go to the one variable calculation, and then my default here is L1, so I just hit calculate. All right, and this X bar is my bin. Okay, so look at this one right here. This one is already found the bin for you, 21.8. So that X bar is the bin. This is the sum of X, which we don't really need to use that. This one is the sample standard deviation. This is the population standard deviation, which we're gonna be able to use that later on. All right. The good news is if you use this one, it also giving you the minimum, the fourth quartile, and then the second quartile, that is the median. Look at that. So if you are tired to find the data by hand, you can also put in a calculator, it will find a median for you, right? So sometimes people call this is kind of like a little bit cheating. You don't find the median on your own, your calculator find it for you. All right, so MED is the median for those data set. And the good thing is if you input a calculator, you do not need to short. Calculator will short it for you, okay? All right, so that is the simple bin. So go to stat, cal, and then using the one variable statistic. The frequency here, default, usually default is 1, okay? Because the data, you input all the data, so the default frequency is 1. You don't really have to input 1 in here. But if I have a different frequency in here, which we're gonna use the weighted bin, we need to input the L2 into the frequency, all right? So for example, if I want to calculate this one, okay? If I want to calculate this one, okay? If I want to calculate this weighted bin, all right? I have a bin point, I have a frequency in here. I can input my bin point into L1, input my frequency into L2, and the calculator will find the weighted bin for you automatically. All right, so let's see how you do that in here. So I go to my stat, edit, I'm going to clear everything out, okay? And then input my fourth one, 172.5. Okay, and then I input my frequency into L2 in here. Okay, so make sure you have a left side and right side are in the same pair, all right? Okay, so now I go to my stat, cal, using the same thing, calculation. My frequency, I want to calculate L1, but I want my frequency into L2. So my frequency is not default, it's not 1, right? Some of them appear more than the others. So I will need to input L2 in here. So I showed you earlier, how do you input L2 in here? Second 2 is L2, all right? And then we're gonna just go ahead, hit calculate. Guess what? This X bar, now this become the weighted bin. Okay, so this will become the weighted bin, which we have in here. Let's see what is our weighted bin for you. Look at this one right here. We calculate this sum of, so our weighted bin here is 287.7. Look at that, this is your bin. X bar is your weighted bin in here, 287.7. It's exactly the same. All right. So that is a quick and easy way. If you do not want to calculate by hand, calculator can handle that for you. You just need to go to state and then cal, move to the calculation, and then using one variable state, the first one, just make sure input your L2 into the frequency list, okay? And hit a calculation, and then that way, this bin become the weighted bin. All right, so that is really quick and easy. Instead of doing the 4-step in here, okay, step 1 you still have to do that. You still have to find the bin point by hand first, but you can do it can help you to do the 2, 3, and 4 all at once. Okay, so that is the weighted bin. Anyone has any question about this calculator use? Any questions? All right, if you have a question, you can raise your hand or you can type it in the chat here, okay? All right, so the next thing here is the symmetry, the shape of the symmetry distribution. As I said earlier, if we have this one, looks like a perfect bear curve, right? If I do a little bit regression, it's kind of going up and then coming down like a perfect bear curve in here. Our triple M, mean, median, mode will be the same. They are all in the middle, okay? And this one is called symmetry. Symmetry distribution. Sometimes we call this is kind of like a bear curve, right? Bear curve in here. All right, so looks like a bear. All right, this one is a uniform, okay? So everything is the same, of course, that's a uniform, all right? Your mean, median is the same for the uniform in here. All right, this one, it looks like a little bit tail to the left. So we call it negatively skew, or sometimes called skew to the left, right? So if you do this one right here, you have a long tail, and then this is kind of like a long tail to the left. So if you have a long tail to the left, the median is always in the middle. Look at it. Median is always in the middle. Median doesn't skew by anything, always in the middle. But if you have a skew to the left, your being gonna follow the tail. The being gonna be on the left, and then your more gonna be on the right. Okay, so you can just know the median is always in the middle, and the being follow the tail. All right, this one is a little bit skewed to the right. Okay, so that means you have a bit data on the right side. All right, so this is kind of right side, a tail, right? So skew to the right, you being gonna be follow the tail. The being gonna be on the right side of the median. All right, the median is always in the middle, and then you more gonna be on the left side. Okay, so that is a little bit this kind of skewness distribution. We also need to be able to identify that way. Okay, so that is our section 2.3 already. Okay, the 2.3, we need to be able to calculate the regular bin, right? X bar for the sample bin, mu is for the population bin, and then we need to be able to find the weighted bin. All right, the weighted bin in here. We need to using the X times the weight, and then divide the sum of the weight in here. All right. Okay, 2.4 here is the measure of the valuation. Okay, so what is the measure of the valuation? We're gonna need to be able to find the range, the variance, and the standard deviation for the population and for the sample. Okay, and how to approximate the sample standard deviation for the group of data. And as I said earlier, we're gonna be able to use a calculator to find this one because it has a built-in formula for that. So this will be pretty easy. We use the calculator, okay? But we still have to understand some of the concept first. What is the range? The range is using the highest one minus the lowest one, right? So sometimes I just write down R will be equal to H minus L. Okay, the highest data value minus the lowest data value. All right, so if we look at these two corporations, each hire 10 graduates, right? And that is their starting salary in here. So you can see in company A, the highest one is 47, the lowest one looks like a 37, right? So the range here will be 10,000 difference. And if you look at the company B, highest one is very high, 58. Lowest one is also very low, 23. So if I look at the range here, okay, so that's 35. The range for the A in here, this is the range for the B. The range for the A here is 47 minus 37, so that is 10. All right, so if you go to work for company A, everyone get paid pretty much similar. If you go to work for the company B, you have to be very careful because you don't want to be praised this one, but you will be happy you will praise that one, right? So that is kind of high is very high, low is very low. So this one apparently got the most valuation, all right? So if we go to calculate the standard deviation, this one deviation will be much higher because the range is much higher. Okay, the value, differently. All right, so that's the using the maximum minus the minimum, that's the range. Okay. And we're gonna look at the valuation. So valuation is kind of how far away from the average. Okay. So like I say, we have this data set right here, right? So if you got paid 45,000, all right, for the entry level job, 45,000, is this 45 about the average or below or above average? That kind of thing. Okay. And then if you have a 4 to 50 in a corporation B, is 50 good or not? Is 50 above the average or below the average, right? And if below or above, how far away? So we're gonna be able to use the standard deviation to calculate. All right, so if you do a little bit of bar graph or histogram, right? This is how the A look like, and then this is how the B look like. Okay, so first, how do we find the deviation? Deviation in here is using, if you have a population using x minus mu, mu is the mean, right? Mu here is the mean. Mu here is called a population mean. All right, x bar here is called a sample mean. They are all mean, but just a little bit different situation. If this represent the population, you use mu. If this data set, say from sample, you're using x bar, okay? All right, so the population variance, okay, you just have to using x minus mu, and then each one you need to square them together before you add them. All right. Otherwise, if you don't square them, you're gonna have some positive, some negative, and add them together will become 0. So you won't be able to calculate the standard deviation. So that's why they square them first before they add them, and then you divide by the n. So that is the variance. That is called a standard deviation. All right. So if we're giving you the variance equal to 9, you can find the standard deviation, right? You can just take the square root on both sides. So your standard deviation will be 3. If I giving you the standard deviation equal to 5, you should be able to find the variance because you just square both sides. Okay, so variance will be 25. So in this case, if you know one, you can calculate the other one really quick. All right, so here is showing you the step of 5 steps to find the standard deviation in here. First, you have to find a mean using sigma x over n, find a mean. The second one, you find the deviation, and then you have to square each one of them, and then you add them together, right? And after you add them together, you divide by the big N, so that's become the variance. If you take the square root, that becomes the standard deviation. All right. Okay, so we have this corporation A in here. So if we use this A, how do we find the standard deviation for the A? Well, this one right here. Okay, let me show you. All right, let me show you how to calculate this one once, and then I'll show you how to use a calculator. Okay, because using calculator is very easy, but you also have to know how this data come from. So let's just do that manually once. And when I said do that manually, I like to put it in the Excel, because a little bit easier. You know, if I had to do that manually, Excel will be a little bit easier. Okay, so I have a company A in here. Make it bigger. All right, so I have a 41, 38. Okay, so I have this so I have this 10 data in here, okay? And then if I want to find a sample mean, okay, I can just highlight this together. Look at that, this big sigma is the auto sum. All right, so I have my sum here is 41.415, right? And then this divided by n here is 10. So I want one decimal point, okay? All right, so that is my sample being. Let's see what it call this one. Is a sample or the population? That is a population. So the population, we're gonna using the mu here. So my mu here is equal to 41.5. Okay. All right, and then we want to go to find a deviation. So what is a deviation? Deviation, we're gonna use x minus mu. X minus mu. Okay, so how do I find my deviation? I will using each data minus 41.5. Okay, and you can see this one. You can see this one is below 41.5. That's why it's negative, right? This one is above the bin, so that's why it's positive. But if I add this whole thing together, what happens? Some of them positive, some of them negative. If I add them together, it becomes 0. All right, so 0, we cannot find the deviation for the 0. So that's why we like to put each one into a square. Okay, square them. So the negative square will become positive, right? If I square this one right here, if I square this one, it will become positive. Okay, so I'm gonna just do the same thing for the rest of them. All right, so now everyone become positive, and then I go to add them together. All right, so now I got this 88.5. Okay, 88.50. So that is my sum. So this one is my sum of x bar minus x minus mu square. All right, so I have this whole thing in here, and then I just need to use this one divided by n. Okay, so use this one. Use this whole thing divided by 10. All right, so that is called my variance. Okay, this one is called variance. Variance is the sigma square. So my sigma square will be 8.85. All right, and then if I take a standard deviation, take a square root. So take this one square root. Okay, so my square root here, if I just want to, let's just run to 1 there. decimal point. Okay, so this will be my sigma, my standard deviation, which is 3.0. All right. So I just showing you do this one by hand, going to step by step in here. Okay, just showing you how do you do this one in Excel, right? I have a this x in here, all right, and then I have a this x minus mu in here. Okay, I have this x minus mu, and then I have this x minus mu square in here. All right, you add them together, we got 88.5. That's exactly the same, right? And then you go to divide by n. So you have this one divided by 10. So that's you got 8.85 or 8.9 for the variance, and then take the square root, you got a standard deviation in here. All right, so that is quite a bit if you have to do that by hand. I think in the homework, you do need to go through this process once, just trying to let you understand the concept. After that, you can just use the calculator, okay? So I can show you how to use the calculator in here. Very quick and easy to find the standard deviation. Okay, so we still need to go to step. All right, we still going to this one right here. So I input 41, 38. Okay, so make sure I have the 10 data right here, right? So after you input all the data, you just go to step, cal, same thing as we did earlier. And then I don't have a frequency L2, so I have to clear that one. So the default is 1. So I just have L1 right here. And then just go ahead, hit calculate. All right, when I hit calculate, in here, all right, let's see, something is different. Okay, looks like my bin is different. Let's see. Let's look at my input. Okay, my input might be different. 41, 38, 39. Oh, you know, that's why I have a this miss input in here. That's why I skew the whole thing, right? So the good news is if you input this one right here, you can you don't have to delete everything. You can just come here to fix that one. So this one should be 45. All right, so 45, 47, 41. Okay, that is about right now. All right. Okay, so now we go to step again using cal, one variable calculation. All right, we calculate. Now we have the bin here is 41.5, right? And this one giving you two standard deviation in here. It gives you both the sample and population standard deviation. Okay, so we have to go to read our data carefully to see which one do we choose. Okay, in our data, okay, our data here is set the population using the mean, right? How do you know it's a population in here? Okay, let's go back to here very quick. All right, so that's a single salary for the cooperation A. So that means that they have at least many people. Okay, that's the population. They say the population in there. Okay, so when you have a set of population, you're gonna using the sigma. This is x of x. So you have a 2.7, 2.97. That's the standard deviation, 2.97, right? Actually, if we put it a little bit more decimal point, this is 2.97. Okay, if I expand this a little bit more decimal point, you can see this is a match, right? 2.7, 2.97, 2.9749 in here. All right, so that is this one right here. If they say this one is a sample standard deviation, now you're gonna choose this one. Okay, so this calculator automatically giving you two numbers. You just choose which one you want to do it that way. All right, so that is the standard deviation for the population. If it's for the sample, is the only thing different. Let me see what is. Okay, so if the data is from the sample, everything else is the same except you divide it by n minus 1. So why we divide it by n minus 1 instead of n? Because the sample usually is a smaller set. So smaller set is not a population, so you tend to make a bigger mistake. All right, so that's why we using the n minus 1. So that way we can not underestimate the variance or the sample standard deviation. Okay, so if you look at the sample standard deviation and the population, the sample standard deviation always bigger. Look at it. X of x is 3.1, sigma of x is only 2.97. So this one is always bigger because this one denominator is 1 less. Okay. Otherwise, the calculation is exactly the same. All right. So if I say this data set is from sample non-1, or if I say this one is from sample, I will, instead of divided by 10, I'm going to divide it by 9. Okay, so I'm using this one divided by 10 minus 1, which is 9. All right, and that will be giving you my sample variance, and then this take a square root. This will become the sample standard deviation. So this one will become this tiny x of x. This one will be the x squared. Okay, and then this will be the x. This is your sigma in here. All right, so that is how you do this type of the calculation. The good news is the calculator always giving you two sets, right? You just need to be able to choose one to use. Okay, so how do you interpret the standard deviation in here? Standard deviation is trying to see how far the data spread out. Okay, if the data spread out more, that means the standard deviation will be bigger. Okay, so look at this one. Everything is in the middle, so there's no spread. So your standard deviation will be 0. This one looks like a pretty standard spread, you know, going up and down. So you have a spread here is 1.2 standard deviation. This one looks like a, you know, pretty much everywhere, right? So it's pretty far away. So this spread is bigger, 3.0. All right, so that is kind of how do you look at the spread in here. Okay, the standard deviation for the group of data in here, well, that is a big formula for the group of the data in here. But I usually say if you have a group of data, you still need to find a sample mean first. And then use each data minus the sample mean and then square them. And then you have to multiply the frequency first before you add them together. All right. But we can put this whole thing into calculator to do that. Okay. So if I have a group of data, I just need to put it in the frequency into L2 in here. Look at that. I can just put a frequency into L2. All right. And then when you go to do the stay here, do the count, and then you just need to put the L2 into this frequency. Okay. So that will be the group of data, and we'll calculate the population mean for you, sample mean, and then the standard deviation, you know, automatically. All right, so that is much easier in here. So look at this one right here. We have this group of data, right? We have a x0 frequency is 10, x is 1, frequency is 19. All right, so how do I find a standard deviation for this group of data, right? If I have this table already, I just input my x into L1, input my this into L2, okay? Otherwise, if you're trying to find this one, you have to find a bin, and then you follow those steps, right? So each data value need to minus bin first, and then square them. And then you have to multiply the frequency first before you add them together. All right, and then after that, you divide this one, so you got a 1.7, okay? But I can put this whole thing into my calculator really quick. So let's input this one in here really quick. Okay, so I have a x is 0. All right, and then this one is 10, 19. Oh, I input one wrong. 10, 19, 7, 7. This should be 2, 1. And the last one is 4. All right, so always make sure your left and right has the same height, okay, same number. Otherwise, if it's not paired, it won't work. All right, and then go to stay and then go to cal, right? And then I have my frequency here is L2. So second 2 is L2. All right, and then we just go ahead here, calculate. So guess what? This bin here is the weighted bin. Okay, so we have this weighted bin here is 1.8. If you round to 2 decimal, round to 1 decimal point, that's 1.8 in here. And then since this one telling you is a sample, okay, so we have a x of x right here. This is x of x is 1.7, right? If I only round to 1 decimal point, so that's 1.7. It's already here, okay? So very easy to calculate in here. All right, so that is how you find the group of standard deviation from the table. Okay, so this one is a group of data. All right, group of data right here, we have to find a mean point. Okay, so after we find a mean point, we multiply the frequency, right? We can input this mean point into L1. Okay, input a mean point into L1, input a frequency into L2. All right, so if you input this one, you can find a weighted mean, you can find a group of standard deviation really quicker from the calculator. All right, so I'm not trying to do that one by hand. Using calculator will be quick and easy. Okay, anyone has any question about this section using the calculator per se? Any questions? Okay, so if not, let's look at our last section for the chapter. Okay, so the last section of the chapter here is the measures of the position. Okay, so we have a little bit of quartiles. Okay, so you have to know how to find the first quartile, second quartile, third quartile. All right, and fractiles. Okay, so finding the quartile usually, you know, a little bit use a little bit more in the statistic, right? So basically, find a quartile is very easy. So, if I have a 1, 2, 3, 4, 5, and 6, and 7, right? And then if I want to find the median, so this is my median, all right, that's my median here. And then we have this separate into two groups. So we have a median separate this into two groups, and then the middle one right here, this is my fourth quartile. Okay, we call it Q1, this is called Q2. And then find the median for the third one right here, that's called, for the second group, that's called the third quartile. Okay, so as easy as something like that, you just find a median for each part. And that's the first part is Q1, and the second part is Q3. Okay. One thing is, if you put in a calculator, all right, so if you put in a calculator, guess what? Calculator find a Q1, Q2, and Q3 automatically for you. Okay, so if you don't want to do it by hand, this one is very easy to put in a calculator to find all of them. So some people call it kind of cheating. Yes. All right, IQR, so it's an interquartile range. Interquartile range, you're just using Q3 minus Q1, right? You can find a Q1 and Q3 from the calculator in here, and then you just using Q3 minus Q1, that's the IQR, okay? One thing is you can use the IQR to identify the outlier. So the outlier can be the lower one, can be the upper one. So where's the lower one right here? Look at that. If you have a Q1 minus 1.5 IQR, if you have something lower than this one, that's the lower point outlier. Or you can use the Q3 plus 1.5 IQR. If you have anything greater than this one, is also an outlier. Anything less than this one is an outlier. Okay, so remember, if we have a Q1 is 23, Q3 is 30, right? Our IQR will be 30 minus 23 will be 7. And then 1.5 times IQR is 10.5. Okay, so if I use 23, okay, I use Q1 minus 1.5 IQR. So that means I using 23 minus 1.5 IQR is 10.5. And that will giving you 12.5. Okay, so giving 12.5. So if you have a data is 10, 10 is less than 12.5. Now 10 will become an outlier. Okay, and then if you have a highest one using Q3 plus 1.5 IQR, which is 40.5. So if you have anything greater than 40.5, that's also an outlier. Okay, so 11 is less than 12.5, so that's an outlier. Okay, if you have a 50, 50 will be greater than 40.5, that will be also an outlier. All right, and then another one right here is called a box and whisker plot, using the white number to represent the plot in here. So basically you have a minimum in here, and then go to the Q1, okay? And then if you have a Q2 in here, this is a Q3, and then you have a maximum. All right, that is called a box and whisker plot, right? So we plot the Q1, Q2, and Q3 using a box and put it in the middle, and then connect to the minimum and the maximum. So that is a plot. That is one graph in here. The good news is the calculator can graph this one for you as well. Okay, so you plug the minimum in, and you drop a whisker to the Q1, and then you have a Q2, you have a Q3, you have a maximum. All right. And the good thing is, if you have an outlier in here, you can graph the outlier. Okay, usually calculator we are using, like if you have something outlier, using like something like a star to identify the outlier. Okay, all right. So let me show you how to graph this box and whisker plot in the calculator. Okay, so if I have this 25 liberal arts college list, okay, one the first, second, and the third quartile, and also we're gonna use this one to do the scatter, not scatter plot, do the box and whisker plot. Okay, so I go to stat, edit. Okay, I'm gonna clear everything. And if I don't want to clear everything, I can input my, if I really want to keep those data, I can just input into my L3, right? So I can input this into L3 if I really like to keep those data there. That's okay. All right. Okay, so my data here is in L3, right? So I just need to make sure I use L3. Okay, so we're gonna go to stat cal using one variable calculation. I don't have a frequency. My frequency default will be 1. So now I'm gonna change this one into my 3. So second 3 is L3. All right, so make sure I use the right data and then I hit calculate. So now I have my mean here is 37.4, 0.04, and that is my sample standard deviation. That's my population standard deviation. I have a 25 data set here, right? And then my minimum here is 16. My Q1 here is 28.5. My median is 36. My Q3 is 48. So look at it, giving you all these numbers. My maximum here is 52. Okay, so I have all the data I want. I can also do the box and whisker plot for this one. The second y equal to, go to the plot in here. This is the box and whisker plot right here. These both are the box and whisker plot. Okay, this one and that one. What's different of this one and that one? This one right here with the dot dot at the end, this one will identify the outlier. On the other hand, this one don't have a dot 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 at the end, so this one doesn't graph the outlier. So I usually prefer to see if there's any outlier, so I like to use that one. So I'm gonna hit enter for that one. Okay, and then remember my list is in 3, so I have to go to the L3. All right, and then we hit graph. Of course, we have to zoom them. So zoom number 9, zoom state. So that is my box and whisker plot in here. All right, so it doesn't look like I have any outlier. Okay, so there's no outlier in here. If there's an outlier, you're gonna have a broken point and then have a little bit kind of start right here. Okay, so that is my box and whisker plot for this one. Okay, and we can find a minimum, maximum right here really quick. All right, look at this one right here. We already found all the minimum, Q1, Q2, Q3, and the maximum right here. All right. So that is the using the calculator, you can graph pretty much everything in here. Okay, another one is called a percentile. Okay. This one percentile, usually you just need to know how to read this graph. All right. So look at this one right here. You have a SAT score. And if you have an 80 percentile, that is about 12 150 or something like that. Okay. So that is the percentile in here. So that means if you score in 80 percentile, right? So that means 80% of the people below you. Okay. So that is the percentile in here. All right, we also want to introduce one of the fourth very important formula is called a G-score formula. Okay, so how do you calculate G-score? It's using the data value minus the mean divided by standard deviation. So that's called a G-score, okay? The one thing is the G-score is called a standard score. Standard score, that means we can compare the score is above average or below average. If you have a positive, if your G-score is greater than 0, all right? If your G-score is greater than 0, that means that is above average, okay? If you have a G-score equal to 0, so that means you equal to the average. If you have a G-score is less than 0, that means this is below average, okay? So using the G-score, we can very easier to identify the data is below or above average. Okay, so how do we find a G-score? This will be our last topic for today. The mean speed of the vehicle along a stretch of a highway is 15 miles per hour, which a standard deviation is 4 miles per hour. Okay, you measure the speed of the 3 cars traveling along this stretch of the highway as 62 miles per hour, 40 miles, and 56 miles per hour. Find a G-score for each speed. Okay, all right. So we said earlier, my G-score here is using the data value minus the mean, okay, minus the mean, divided by the standard deviation, or sometimes we're using x minus mu over sigma. All right, so the first one, the mean, so this is the mean, so mu here is 56. Standard deviation sigma here is 4, right? And then we have these 3's 1, 2, 3 need to calculate. 1, 2, 3 need to calculate. All right, so the first one here, G will be x here is 62 minus the mean here is 56 divided by standard deviation will be 4, right? So this will be just 6 over 4 or 3 over 2, which is 1.5. We know 1.5 is greater than 0, so that means this one is above the average, okay? All right, second one right here, my G-score, data value is 47 minus 56 over 4. So that's negative 9 over 4, which is negative 2.1 something. Okay, 2.1 something. All right. So this one is less than 0. Less than 0, that means below average. Okay. And then I have a third one. G-score here will be 56. 56 minus the mean here is also 56 divided by 4. So that's 0 divided by 4. 0 divided by 4, we call this one is okay. All right, if you have a number divided by 0, it will be a no, undefined. All right, so this one is okay, it's 0. All right, so what does 0 mean? 0 means this is equal to the average speed here. All right, so that is how you calculate the G-score. We're gonna use the G-score later on for a lot of things, right? But this is kind of giving you a little bit idea on how to calculate the G-score. Okay, I think we just finished 2.5, which is the chapter 2. I'm not trying to open a chapter 3 today because you have a test 1 is due by Monday. Okay, so hopefully you will be able to finish this one on time. The first 2 chapters is kind of more concept-based calculation. When you got to chapter 3, now we're gonna start getting a little bit more calculation, all right? So that is it for tonight. The rest of the time we want to try to see if you have any question, Q&A. Any questions? Okay, I'm also gonna stop the recording.